Hey there guys. So this is going to be the second video that I'm making on Newton's law of cooling, and it's piggybacking off of the same example that you should have seen in the first video where a student bought a frozen drink at a coffee place and they had to make a determination to see how much, uh, do some work to be able to find the uh, constant proportionality, the K value, what the initial value of the function was going to be, what the A value was, and use that to be able to find what the initial temperature of the drink was at 0 minutes when you first got it from the vendor at in the drive-through. So we worked that out, and we were able to come up with the equation that the specific or the general equation that we would have gotten was P of T, the temperature after time, was equal to negative 60 times e to the, uh, and k, we worked out k to be a relatively obscure number of negative natural log of 2 over 10 times time plus the temperature of the constant temperature of the vehicle, which was 65 degrees. So we had to do some work, and this is negative. We had to do, all right, let me clean that up a little bit. Pen doesn't want to work very well. We had to do some work to figure out what the A value and the K value were going to be, but when we were done, we got this particular equation, and that's how we were able to show that uh, the initial temperature of the drink was 5 degrees. And now what we're being asked to do is relatively simple exercise, plug some things in and just use some normal algebra. We're not really using any calculus here. When would the drink have a temperature of 63 degrees? So when is, so we want to find time in this case, and t of that period of time is going to be 63 degrees. So we're going to go ahead and just say 63 degrees. So 63 degrees is equal to negative 60 e to the negative natural log of 2 over 10 times t plus 65. So we begin by moving the 65 over through subtraction, and it'll give us negative 2 to be equal to negative 60 times e to the negative natural log 2 over 10 times t. Now you divide both sides by the negative 60. Negative 2 and the negative 60 simplify to be a positive 1 over 30 to be equal to e times, or e to the negative natural log of 2 over 10 power times t, or times t power. And from here, you just you take the log loop of both sides because we have to get the t out of the exponent's position in order to be able to solve it. So we're going to get the natural log of 1 over 30 to be equal to the uh, negative, or negative, doesn't really matter where you put the negative sign, negative natural log of 2 over 10 times t. So I'm going to divide by the negative natural log of 2. So I'm going to just, and we're just using a calculator to type this stuff in. So we're going to get negative, or natural log of 1/30 over negative natural log, oops, I can't, not writing that denominator properly, negative natural log of 2 over 10, and you're just going to type that into your calculator. That would be good enough for the exact time as far as I'm concerned. And when you type that into your calculator, you're going to get 49.0699 minutes for the approximate value of time for the drink to rise to a degree, or rise to a temperature of 65 or 63 degrees. And the last thing that it's asking you to look at is what would the temperature of the drink be after 1 hour. Now, because of the nature of these things. They have a tendency to kind of have horizontal asymptotes. So to say that it's going to, excuse me, that came out of nowhere. I apologize. To say that it's going to be exactly 65 degrees, they're going to say, oh, you're just going to approach that asymptote. You're not actually going to be able to get it. But you know, I don't know. Warm day can warm up pretty well. I don't know. Depends. What would the temperature be after 1 hour? And this is a very simple plug and chug exercise for 1 hour. And in this case, we need to go back to the original problem because they're giving us our time value. They're giving it to us in minutes. They're not giving us time to be done in hours. So when we say, in this case, we're going to substitute 60 minutes for 1 hour because, excuse me, time was done in minutes for this particular problem. So we'll say T of 60 in this case. This is a very simple plug and check exercise on your calculator. And we're going to have negative 60 times e to the negative natural log of 2 over 10 times, in this case, 60 power plus 65. And you'll just type that directly into your calculator. And you'll say T of 1 hour or 60 minutes would be approximately equal to 64.063 degrees Fahrenheit. And that is essentially what we're going to be looking at for Newton's law of heating or cooling. You will, depending on the problem, especially for a calculus class, be given a differential equation that you either are given or you have to figure out what the differential equation is. Find the general differential equation solution and then find the specific solution for the problem that you're looking at. And you're definitely going to have to remember some logarithm properties, some log loops to try and convert exponents to logarithms or vice versa, depending on what you're solving for and where it's located in the problem. But once you have those equations, the calculus is, once you have your essentially, once you have solved your differential equation, your calculus is done. The rest is simply algebra. But the algebra can get a little complicated at times. But that's going to wrap it up for the videos I'm making for Newton's Law of Cooling. Thanks for watching, ladies and gentlemen. Take care and be good.